Thank you. Thank you very much for the invitation. Like you said, I'm a mathematician, or I used to be a mathematician. And so this was the type of stuff I used to do when I was doing research. So I was in pure mathematics, and some of those things I call higher category theory, and homological algebra, algebraic geometry, all those super nice stuff. If you don't know what it is, you should check it out. It's very nice. But that was before, and this is basically my background. I started my PhD at Oxford University, and this is the coat of arms of my college. Little ducks, then I went to UCLA, back to England in City University of London, and then now I just became a bird. So this is the Deku logo. So quick word about Deku. Deku, we're a French-based startup. We're now 3 years old. We have over about 50 people. We opened an office in New York about a year ago. We also have people in San Francisco now. Basically, we have about 80 clients. I just named 2 because they're French and people know them. So it's L'Oréal and AXA. And we only do one thing. We do a platform, a software, which is called Deku Science Studio, DSS. And we aim to help people develop their data-driven products and build their data lab. And I'm a data scientist, that's what I do at Deku. So I also help people build their own data science project. Okay, so I want to start very strong. What's wrong with data science? So if you've been in the field for just about enough time, you come to realize that you often do the same thing over and over again. Like if you give me a data set with a problem, which is, churn reduction or fraud detection, I do it, I spend weeks, perhaps months, everybody's happy, and then you say, okay, now I have another one, it's another fraud reduction problem, and I have to start over again. And perhaps it's the same data set, and you just like subtly tweak it. Maybe you just change some columns or something very slight, but I don't know, because I have over 50 columns, and I still have to go check one by one, and I will spend about the same amount of time. But sure, I gain experience, I know tricks, I know what not to do, but still, as a scientist, as a mathematician, it feels very wrong. Like I'm doing the same thing over again. And if it was an infomercial, I would like to say it has got to be another way. So often I feel Greek. I feel like Sisyphus doing the same thing over and over again. And so today what I like to think is if we can find a good framework to try to better understand how to raise this data science problem and how to answer them and what's been currently done. Okay, so let's start from the basic. This is the data science process. So it's a very schematic way of thinking about the problem. You have the data, and perhaps you have a question. You have data cleaner. Those are actually data cleaner, like it's the job, to clean data centers. And then you have the guy in the matrix picture who I guess is doing fishery engineering and super hardcore stuff. And then when he's happy, he gives you a model, and then perhaps you also have an interface. Maybe it's an API you can create, and then he gives you prediction back, and then that's it. So without the images and in more PowerPoint-like, it will be the first part correspond to cleaning and pre-processing. That's what some data analysts do, or data cleaner. And then you have the feature engineering part, and those are the 2 main parts. But like I said, in real life, things are way more complicated than that. Like I just put a few loops here, but there should be many loops. Like there could be loops everywhere. Like you start to clean, then you do a model, then you go back, and then you're thinking about a new feature. So actually, in real life, the data science process is pretty cumbersome, I feel. So now that we know what we're dealing with, the question is, okay, what can we do here to have a better go at the process? Where in this picture can we do something in a better way so that I don't have to do the same thing over and over again? So I might want to think things like automatic system or automation, and once I get thinking about auto, if you Google it, like auto data science, auto machine learning, then the first comes to mind is this field called AutoML. AutoML is for auto machine learning, and it will try to automate each of those boxes to make your life easier. So what is auto machine learning, pretty quickly? So this is basically replacing by robots everywhere. That's the idea. Like you don't want to have someone do it, you want to have robots do it for you. And you have a robot cleaner and a robot engineer, and it should remain the same thing. In real life, there's a lot of companies, there's a lot of startups that do this at every single step. Every single box, like I say, could be potentially optimized by auto machine learning approach. So I just put a few on that this feature lab, which comes from the MIT as is part of a bigger picture, but they focus on doing feature engineering and discovering new features. And there's a SIG-Up, which is very interesting. The little guy here with the Sigma, they only do hyperparameter tuning. So you have to do basically almost everything up to the model, and you give them your model, and they charge for you, and it's actually pretty expensive. And then they give you like what should be the best parameter for your model to work. So those are always a local solution, and some guys try to have a more global solution. So those guys here, they try to tackle the whole process, the whole pipeline. So the guy at the bottom is it's the only picture I could find for the automatic statistician, which is a project that comes from Cambridge, England. And there's another guy from NU for Newtonian and Feature Lab again, and also some German guys. They started an auto scikit-learn. So scikit-learn is a popular library of machine learning, and that is very much used, and it's open source, so it's very easy to use. So the attempt of auto scikit-learn is auto scikit-learn is to scikit-learn what auto ML is to ML. So this makes sense. And so, but here at least they're trying to think about a global approach of the whole problem. Behind the scene, technically, for tech people, it's just Bayesian optimization problem everywhere. So everything becomes naturally a loop. And but when we say Bayesian, also we say black box a lot, and there's a lot of things that we don't really control very well. But if you're not a tech guy and you see all of us company, all of us startups that do this, it makes me feel that, well, it should make sense, right? Like there's a marketplace for that. Perhaps there's even a need, and perhaps people, will enjoy those kind of solutions. And actually, I think it actually makes most of the marketing speech very, very easy, because this is what Wet Lab, which does not exist anymore, thankfully, because of what they're claiming. They got acquired by Twitter about a year ago, and they're basically saying, like, we don't need data scientists anymore. If you work with us, like, everything will be automatic, which sounds nice, because we all know that it's hard to hire tech people, and we don't know what they do. We don't know how to ask them questions. Very weird people. So just trust me. Buy my stuff, and you don't have to talk to any coder anymore, basically. It's a bit of a shortcut, it's not that far. And I think it sells very well, because all of this idea of like, okay, we're gonna replace things by robots, and it will be cheaper. So it got me thinking like, oh well, it does not sound very good. It does not sound very good to me as a data scientist. So I really want to think like, oh, to machine learning, really? Because if the idea is to kick the data scientist out of the data science process, well, I have to think twice. And if you think about it even more, you come to realize that this is weird, because as data scientists, as machine learning researchers, or software engineers, we're actually building the tool that aims to replace us. So I don't know how I feel about that. But could it be that we used to say very quickly data scientists is the sexiest jobs of the 21st century? That's something we heard a lot from the past years, but, well, the shortest century then, or something, I don't know, perhaps data scientists will be on the path to extinction. So what I just mentioned to make me think of this theory in economy, which is called planned obsolescence. So it originates in 1932, something like that, in the middle of a hard economic time in the US, and this idea is like, well, if we want to have a better economy, perhaps we should plan to shorten the lifetime of the product we made. So this is the article of this guy, Bernard London. And it's very controversial to think about this, and there's a lot of issue that people keep talking about. Is there really a planned obsolescence? Because that would be real weird. But I just went on Google Trends, and I was looking for two search. I was looking for new iPhones, and which is in blue, and iPhone slow, which is in red. So I couldn't really zoom on Google Trends, but you really see that the two are very much correlated. This is not saying that when a new iPhone comes out, your old iPhone is actually slower. It might be saying this because you have to upgrade to a new iOS or something, I don't know, but actually people have correlated behavior about that. So that would be, if you want, an example of planned obsolescence. Forces you to, I have an old iPhone, it's not the same USB now, so basically I'm screwed. And now, if you think about it back to the data science picture, it will be like we planning our own obsolescence. So it will be like self-plan or auto-plan obsolescence. And I think it's a bit ironic to put ourselves out of the jobs in 5 years. So I guess that would be my first reasons that I don't like auto machine learning, or at least the way it is advertised outside right now. But I think we out to see a better, more structural reason why I think there's often something wrong with auto machine learning. The first thing, well, it's building on my trust issues. Like I say, auto machine learning is a big black box. You don't know what's going on. And there's this nice article which does not really talk about auto machine learning, but it talk about something that Danny talked earlier. For the next Netflix prize, they did an ensembling about 100 different models. And the way you ensemble everything, it's very hard to understand exactly what's going on, to interpret the models. And so that raises a question: how can I really trust the prediction of each and single one of the instances of a model? So we don't feel confident with that black box attitude. And I really think that we could even state some kind of like a theorem guess, which is like the time you will spend understanding a black box should be about the same at some point, depending on the complexity, by the time you would spend if you were to do it yourself. So I don't really see the point, because if I do it myself, I will know everything about it. I will be responsible for my choice. But if you just give me a big black box that took hours to train, I might have to spend a lot of time understanding, oh wait, why is this doing this right now? Why those features got rejected? Why did it choose this algorithm? And well, if you need to report to someone, that might be a worry for some of us. And for people who have to deploy things into production, this is the final question comes from this point, is will we really deploy something into production which has been automated from start to the end? And I think it's a very big question, and that's why I think we should be very careful with auto machine learning, as it is right now. So back to Greek mythology, Sisyphus is not doing any better, I think, with auto machine learning. It's not making our life easier as a data scientist. It's very nice for the fine-tuning at the very end, but for the whole pipeline, it's very dangerous. And we might want to think that we could find something better to do. And also, yeah, last point, I think, who will you blame if something goes wrong and you have no data scientist? Like, I think this makes no sense for no one. Like, you need someone to blame if something goes wrong, if the prediction crashes, or something like that. So that would be an extra reason to be very careful with auto machine learning. Okay, well, like I say, I'm a mathematician, so when I don't know what to do, I just go back to my math and see, well, can I gain some knowledge as a mathematician? And if I were to sum up, I have a very bad memory, but there's only two things I remember from my time doing mathematics. Those were two things: looking out for elementary structures, and the other one, which is functional behaviors. So we don't worry about this, but the idea of structures is that I don't believe that object possess interesting properties, that they're really defined by their external relation within a system. And functional behavior, we won't talk about, but if you do functional programming like Scala or Haskell, that will be similar to those things. And if I push this thing further, the mathematical approach, this leads me to a very scientific way of thinking. If you give me a big problem, I want to be able to divide this big problem into smaller bricks that I will be able to understand better, and then I will want to understand any given problem as a combination of those bigger bricks. And looking out for the smaller bricks, this is looking out for elementary structures, if you will. And for data science, that will be understanding a data set, will be understanding it into terms of smaller structures. Greek again, the road for that, for looking for smaller bricks, is called isomorphism class, or just say that they have the same shape, and this is really what we do. So now I think at least we're getting closer to phrasing correctly what we really want from a mathematical approach to data science. Okay, so now that we've phrased everything and we got some mathematics, I think it could help us getting back to the data science process. So, like I said, I think Sisyphus is not doing better with auto machine learning, but now at least I know how to phrase things. How to compare it to data science problem, it means I want to look for this thing called isomorphism classes. I want to be able to say, well, those two problems, they are the same. Because if I'm able to do that, then I won't have to spend the same time that I did on the second problem at the time that I did on the first problem. As a technical bonus, when we say that auto machine learning is based on Bayesian optimization, Bayesian optimization often suffer from something which happens to echo what Danny said, which is cold start. It's very hard to know how to start a Bayesian problem, and this could provide a warm start, actually, to the Bayesian optimization problem. So actually, we could combine this approach with the classical auto machine learning approach. Just to finish, I would just want to talk about two ideas, two different methods that try to tackle this and try to do this. The first one, it comes from the people who start doing auto scikit-learn, and so we see this this whole picture of what it should be for them to do an automated data science process, and this second box, meta learning, it is really what I focus about. So what they do is they say we can represent a data set by some meta features, the number of features have, numerical, categorical, so that each data set is represented by some features. Then you can compute some distances, some similarity between two data sets. And then when you get a new data set, you have access to its meta features, so it's very easy to see to which other data set it looks like. And from that point on, you can propose the machine learning model that did well on the data set, which looks the most like the data set you've just tried. It's somehow, we can think of this in different ways. The first way would be to think of it as being a nearest neighbor approach on data set. But I'd like to phrase it differently, and it echo again recommender system. We could think of it as being a huge matrix of data set and features. So we will put data set and we'll put the value of each meta features. I put it here, some of the meta features that those guys use. I think there's a list of over 40 or 50 different features. And then you do a recommender system. You just do a recommender system on your data science problem. Talking about features and meta features of the data set, I think there's a big problem because it's very hard, because it doesn't suffice to have the same number of categorical variables to understand two data set problem. There's a lot of things going on. So I just want to mention very quickly something that came out of Stanford University, which is called topological data analysis, aka TDA. And there's a company that's built on that. It's called ISD. And basically, they're trying to have a topological understanding of a data set. So you will have picture like that I will not explain, but they will really understand the real topology of a data set. And that will be a very, very strong features to understand data set. And then you will be able to compare two different data sets. And as a bonus, as a mathematician, it is very much functional theory. So you know that it will be preserved under some kind of transformation. So if you give me some data set that you just tweaked, you just took a transformation, you apply a log to it, you just add a square, it will give me the same signature as a data set. So that would be great to have this. And last but not least, back to recommender system, there's another approach which is combined from different research. Some come from MIT, over from CNRS in France, and it's to do collaborative filtering for machine learning pipelines. So you have data sets, which are your columns, and then you have approach. I want to say approach because I don't want to say machine learning models. You should not only restrict yourself to machine learning models, because as we've seen, the process is much bigger, so you want to understand everything. Should I tokenize this text? Should I not tokenize it? Everything along the way is a question, and it's part of a bigger approach. And then you have this matrix, and this matrix you have scores, and once again you're back to something that we know very well since Netflix, for most of us, which is a recommender system, and this works very well. So I hope this gives us an idea of a better way to tackle doing new problems over and over again. This is just a very scientific approach to better phrasing experience, because the point being that, oh well, it looks like this other data set, this other problem that I know, and I knew this one, so I could warm start my understanding of the new project with what has been recommended here. And I think that's about all I want to say.